Right, thank you. Yeah, I'm not Adrian Griffin. As you can see, Mike Vasey, I head up the Battery Materials Group for Lithium Australia. Unfortunately, Adrian was detained in Australia this week. Sort of a series of converging commitments has kept him there. So I'm in London unexpectedly, and with me the CFO of Lithium Australia, a gentleman by the name of Barry Woodhouse. So hopefully we see many of you around the convention and look forward to catching up over the next day and a half. So there we go. The presentation consists of about 20 slides. It's quite busy, so I'll skip through it at a high level and hopefully leave a few minutes for questions at the end. Standard sort of disclaimer. Lithium Australia is a ASX listed entity in Australia. Lithium Australia is interested in energy metals and specifically those that go into lithium-ion batteries, driven by a search for disruptive process technologies and also sustainability. They sort of drive the opportunities that Lithium Australia look for, and Adrian Griffin has been quite busy in the last couple of years securing resources, alternative mineral resources for lithium, and also most recently acquiring a process technology company called VSPC, which I'll talk about in some detail. That transaction was completed in February of this year and is about the synthesis of cathode materials for lithium-ion batteries. So these are the three specific project areas that Lithium Australia is advancing. The first one is Silage, which is sort of a novel process technology for the extraction of lithium and co-products from sort of non-conventional lithium-bearing minerals. The second area is VSPC, very small particle company, recently acquired pilot plant facilities in Queensland, just on the outskirts of Brisbane. And the third area, ARC, is another entity fully owned by Lithium Australia, focused on the recycling of lithium-ion batteries and other battery materials to recover the metal and put them back into the battery cycle. This is what we term Adrian's wheel, so it sort of illustrates the connectivity between those three project activities. So we have Silage here for the lithium extraction and other co-products, VSPC process technology synthesising cathode material for lithium-ion batteries. Batteries get used and then recycling to take the spent batteries, recover the metals in a form that can be integrated back into either the silage process or, more likely, directly back into the cathode material synthesis. There's a natural connectivity between the three areas, but they all stand alone as separate projects and can run their own course in time. So just a bit of detail on each of those three areas. Silage is a sulfuric acid-based technology for the extraction of lithium from mica and other silicate-type minerals. It uses sulfuric acid at high temperature with calcium fluoride. The fluoride it has a catalytic effect, so it allows for the faster extraction of lithium and digestion of the rock. Best coupled with a sulfuric acid plant, so not only the acid but the energy credits, so to speak, can be used in the process. The objective for this technology is to achieve an operating cost that's sort of less than $3,000 a tonne on a lithium carbonate basis. That includes, importantly, the byproduct credits from materials such as potassium sulphate, also other products such as aluminium fluoride are being considered. So that's the objective for Silage. Third slide on Silage. The status of this project work on the development of a large-scale pilot plant is well advanced, and a decision on building this facility in Western Australia is pending early next quarter. So a site's been selected next to an established industrial site in Western Australia. A raw material's been secured for the project, and the intention is to build that facility at 1/10 of commercial scale, demonstrate the technology over the next 2 years, and sort of build confidence in the technology, after which it can be deployed commercially. So that's Silage. VSPC, this company has a 15-year history. It was born out of research at Queensland University in the early 2000s. The team took it forward, applied this process to the synthesis of catalytic materials, and then about 10 years ago turned their attention to cathode materials for lithium-ion batteries. It's quite a novel process. The company was nearly sold 3 years ago, but the transaction fell over at the last minute due to some other commercial factors associated with a large international chemical company that were about to purchase the technology. It's been dormant for 3 years. Lithium Australia acquired it. The transaction was completed in February. We're just rebuilding the team currently. Not sure where the receiver is for the... just a little bit of detail about the process. It's quite elegant. It involves taking the metals required in the cathode material in solution. You add a surfactant, which is fundamentally a fancy detergent, create what's called a micelle, which is like a microemulsion in simple terms, and then you evaporate the water and the surfactant from that material, and you crystallise the nanostructures, if you like, that are required for the cathode material. You then heat treat it, and you end up with the final stable sort of mixed oxide forms required for the cathode material. It's quite elegant. You end up with a very uniform material with consistent sort of physical and chemical properties which are required for the cathode material. Minimum rework of intermediate type materials, and lower overall energy inputs compared to conventional synthesis processes. So it has a cost advantage, and it produces uniform properties which give you high performance. In terms of product development, VSPC has one product which is ready to go. It's been through about 4 generations of product development. That's LFP, which is a chemistry quite often used in storage and large platform transportation applications. Very big in China, and will continue to be so. Other products which are sort of at earlier stages of product development, lithium manganese iron phosphate and nickel manganese cobalt, which is the favoured chemistry for EV, so they will be developed over the next 2 years. There's a program for VSPC, 2-year program essentially to get product back in the market with major battery makers. In the meantime, complete a feasibility study for a commercial scale plant, likely to be in Australia somewhere, but it could also be overseas. So that's a 2-year program requiring about $7 to $10 million Australian. Recruitment has commenced. Our permanent staff have started in recent weeks. We've brought some of the old team back together. The previous scientists sort of went back into university ranks and industry, so we've brought them back in, commissioned the laboratory, and things are underway. The third area of activity is recycling. We're doing work at 2 universities on both lithium-ion batteries and alkaline batteries. Important for the longer term. There's not a lot of volume out there right now, but it's going to be a critical part of the cycle in the future. So I'll just move to the summary page. So we have silage, we have cathode material technology, process technology, and we'll close the loop with the recycling. Number of attributes there. We commenced the process development for the lithium-ion battery recycling, as I meant. Pending decision on the large-scale pilot plant for silage early next quarter. Corporate summary: George Bork, Chairman. sort of well known in West Australian circles. Adrian Griffin, Managing Director, and Brian Dixon, sort of well known mining people in Australia. So I'll leave it at that. Happy to take a few questions. Thank you very much.